Welcome to our deep dive today.
Oh, it's going to be a good one.
We'll be tracing how our understanding of the universe has evolved, kind of looking back at how we got to where we are now.
Sounds fascinating.
Our guide for this journey.
Let's hear it.
Excerpts from the science book, Big Ideas Simply Explained.
Love that book.
Get ready for a crash course on those big scientific milestones, from like ancient Greek theories about the universe
Oh, wow, way back.
to some of the mind-bending discoveries of modern physics.
It's going to be a wild ride.
All the way, yeah.
It all starts with those fundamental questions about reality,
Yeah.
The questions humans have been asking for centuries.
What's it all made of?
Exactly.
Okay, let's rewind all the way back to ancient Greece.
Right.
We've got these early philosophers, Thales, for example,
Yeah.
trying to figure out what the universe was made of.
Big question.
Thales, he believed it was all water.
Interesting.
Of course, we know that's not quite right,
Right?
but it was a starting point, wasn't it?
It was. And what's interesting isn't so much the specific answer, but the question itself,
Yeah.
They were searching for that unifying principle, that fundamental building block
Yeah.
that could explain the huge diversity we see.
So they were laying the groundwork for scientific inquiry, even though they didn't have the sophisticated tools and methods that we have today.
Right.
But they didn't always get it right.
Like who?
Aristotle, for example.
Oh, yeah.
He was convinced that heavier objects fall faster
Okay.
than lighter ones.
Interesting.
And this idea persisted for a really long time.
It's amazing how even the most brilliant minds, sometimes
Yeah.
they can hold on to these incorrect ideas.
Yeah.
Especially when they don't have the means to really test them.
Right.
Yeah.
Rigorously. Makes you wonder what truths we accept today might be proven wrong in the future.
It's a good point. It's a good reminder to stay curious
Definitely.
and question everything.
Question everything. Exactly.
The history of science is full of these overturned theories,
Right.
paradigm shifts.
Absolutely.
That's what makes it so exciting.
Yeah. For sure.
Now, okay, imagine you're just chilling in a bathtub
Okay.
and suddenly you figure out how to determine the purity of gold. That's Archimedes'
Yeah, the Eureka.
moment. Exactly.
That story's been with me since grade school.
It's a classic. But his insight into the principle of buoyancy
Yeah.
wasn't just some clever solution to a problem, right?
Right.
It was actually a fundamental law of physics
Wow.
that applies to objects floating in any fluid,
Mm.
from ships in the sea
Okay.
to balloons in the air.
It's it's a great example of how these scientific discoveries can
Yeah.
have far-reaching applications that go
Applications.
way beyond the initial problem that they're trying to solve.
Totally.
So from ancient Greece, let's fast forward now
Okay.
to the Islamic Golden Age.
Ah, yeah,
This period of just incredible intellectual flourishing.
A melting pot of ideas.
We've got the House of Wisdom in Baghdad.
Yeah.
Scholars are translating these ancient texts and making their own groundbreaking contributions.
It was a truly cosmopolitan center of learning.
Right, drawing scholars from all these different cultures and faiths.
And their work had a huge impact on the development of science later in Europe.
It's fascinating how knowledge transcends borders and time periods.
Yeah.
Makes you realize that history of science,
Right.
it's not a linear progression,
It's not a straight line.
but it's more like this tapestry
I like that.
woven from these contributions from all these different cultures across the globe.
Beautiful.
And during this Islamic Golden Age,
Yeah.
we see thinkers like Al-Tusi
Yes.
exploring these ideas that almost foreshadowed later scientific breakthroughs.
Right.
He made observations about animal behavior and adaptation that kind of hinted at evolutionary processes.
Centuries before Darwin.
So the seeds of evolutionary thinking were already being planted way back then.
They were just waiting to be fully developed.
It's fascinating.
And Al-Tusi wasn't alone.
Oh, who else?
Al-Hazen,
Okay.
a pioneer in optics and experimental science.
Interesting.
He questioned those long-held beliefs about vision. He insisted on testing theories through observation and experimentation,
So important.
which laid the groundwork for the scientific method as we know it.
It's amazing how these early scientists were already emphasizing empirical evidence,
It was a key turning point.
which would become a cornerstone of modern science,
For sure.
challenging the idea of just accepting theories based on authority or tradition.
That questioning spirit, so important.
Paved the way for the scientific revolution.
Oh yeah, here we go.
This period of radical transformation in our understanding of the universe.
Huge change.
We're talking Copernicus, Galileo, Newton.
The big names.
Names that are just synonymous with challenging norms, right?
Absolutely, overturning those long-held beliefs.
Yeah, it was like the scientific world was turned upside down during this period.
It really was.
Copernicus dared to suggest that the sun, not the Earth, was at the center of the universe.
Oh.
And Galileo, armed with his telescope,
Yeah.
provided evidence for this heliocentric model.
Bold move.
And this wasn't just an abstract debate.
Right.
It was a challenge to the church's view of the universe.
Yeah.
And humanity's place in it.
A major clash between science and religious authority.
Definitely.
Galileo, he was a true rebel.
Wasn't afraid to go against the grain.
Even when it meant facing opposition from these powerful institutions.
Yeah, he was a champion of evidence.
Right.
A master of experimentation.
His experiments on motion, particularly his observations of falling objects,
So important.
laid the foundation for Newton's laws of motion.
Oh, wow. And universal gravitation.
And then there's Newton,
Yeah.
who quite literally wrote the book on gravity.
That Apple story.
Legendary.
Newton's law of universal gravitation explained why objects fall.
Yeah.
Why the moon orbits the Earth.
Okay.
Even how the tides work.
It's mind-boggling to think about the sheer scope of his work.
Truly groundbreaking. And its impact on our understanding of the physical world.
From the grand scale of the cosmos.
As the microscopic world.
Yeah, a realm teeming with these invisible wonders.
It's time to explore the discoveries that revealed a hidden universe within our own.
It's like discovering a secret world, right?
Absolutely.
A whole new dimension of reality.
We're talking about the invention of the microscope.
Yeah.
It opened up this new dimension of reality.
Challenging our understanding of life itself.
Tiny creatures, invisible to the naked eye.
Swimming in a drop of water.
We've got Robert Hooke.
Okay.
Observations of cork under a microscope led him to coin the term cell.
And then there's Antony van Leeuwenhoek,
Yeah.
a Dutch scientist who built his own incredibly powerful microscopes.
Wow.
Revealed the existence of animalcules
Tiny creatures.
swimming in pond water.
It's amazing how a single invention can lead to such a profound shift
It really is.
in our understanding of the world.
Along with these microscopic discoveries,
Yeah.
we also see the birth of modern chemistry during this era.
We're talking about figures like Joseph Priestley, who isolated oxygen.
And Antoine Lavoisier,
Right.
who revolutionized our understanding of combustion.
It's incredible how scientific progress
Yeah,
often involves overturning those old theories
to make way for the new.
to make way for new ones. Exactly.
And in this case, Lavoisier's work
Yes.
helped establish a more accurate understanding of chemical reactions.
His emphasis on precise measurement and careful experimentation
So important.
set a new standard for chemical research.
We can't forget Henry Cavendish either,
Oh, yes.
who discovered hydrogen and figured out that water
Right.
was made of 2 parts hydrogen and 1 part oxygen.
That's such a fundamental discovery.
It is.
It's amazing to think that was once a mystery.
But Cavendish, he was a bit of a character, wasn't he?
Yeah.
Shy, eccentric.
Yeah. Reluctant to publish his findings.
Makes you wonder,
What else might have remained unknown for longer?
Yeah, if not for his colleagues.
Science is a collaborative effort, isn't it?
It really is.
Discoveries building upon the work of others.
So true.
So, from the microscopic world,
Yeah.
the intricacies of chemistry,
Hmm.
we're shifting gears now to earth sciences and the vastness of geologic time,
The dynamic nature of our planet
how it's been shaped and reshaped over millions of years.
and how life has evolved alongside those changes.
Okay, our next stop takes us to Scotland,
All right.
where James Hutton, a geologist,
Yeah.
challenged that prevailing view of the Earth as static, unchanging.
Right.
He proposed that the Earth was constantly being shaped and reshaped by natural forces.
Over vast periods of time.
His concept of deep time was revolutionary.
It really was.
He argued that the same processes we see today, erosion,
Yeah.
sedimentation,
Volcanic activity
all of those,
have been operating for millions of years.
slowly sculpting the Earth's landscapes.
Amazing.
And then we have William Smith,
Who was that?
a surveyor who meticulously mapped the geology of England and Wales.
Okay.
He noticed that different rock layers contained distinct fossils,
Interesting.
providing this glimpse into Earth's history.
His work was groundbreaking.
Absolutely.
His meticulous mapping
Hmm.
and those insights into stratigraphy
The study of rock layers.
gave us a framework for understanding the relative ages of rocks
Right.
and the fossils they contain.
It was a crucial step in reconstructing the history of life on Earth.
Amazing how they pieced together that vast timeline.
Layer by layer, fossil by fossil.
Their work set the stage for the development of evolutionary theory.
Which would fundamentally change our understanding of life itself.
Speaking of evolution,
Yeah.
Jean-Baptiste Lamarck,
Okay.
a French naturalist,
All right.
proposed an early theory of evolution, although it was flawed.
In what way?
He believed that traits acquired during an organism's lifetime
Okay.
could be passed on to its offspring.
The classic example is the giraffe stretching its neck
Right.
to reach those higher leaves, and that longer neck being passed down.
Exactly.
Of course, now we know that's not how inheritance works.
Right. But Lamarck's ideas, though ultimately incorrect,
Yeah.
were influential.
Okay.
He recognized that organisms change over time,
Yeah.
adapt to their environment,
Right.
even though his mechanism of inheritance was off.
His work paved the way for Charles Darwin,
The big one.
whose theory of natural selection
Yes.
revolutionized our understanding of how life on Earth
Has evolved over millions of years.
Darwin's voyage on the Beagle,
Right.
his observations of the diversity of life,
The Galapagos Islands.
yeah, and his insights into the struggle for survival.
It all led him to develop his groundbreaking theory.
His book On the Origin of Species, published in 1859,
Such an important book.
laid out the principles of natural selection, variation, inheritance, and survival of the fittest.
It was a simple yet powerful idea.
It really was.
It explained the incredible diversity of life,
That we see all around us.
how species change,
Yeah.
and how they adapt.
Darwin's theory was truly groundbreaking.
But there was still a piece missing. Yeah, Darwin couldn't explain how traits were passed down.
From one generation to the next.
Exactly.
Okay, so who filled in that piece?
Enter Gregor Mendel,
Okay.
a monk with a passion for pea plants.
Interesting.
His meticulous experiments revealed the basic principles of genetics,
That's huge.
laying the foundation for our understanding of heredity.
Mendel's work, though largely ignored during his lifetime,
Right.
provided that missing link in Darwin's theory,
He discovered that traits are passed down through these discrete units.
which we now call genes.
And with that discovery,
Yeah.
the two pieces of the puzzle finally clicked into place.
Leading to the modern synthesis of evolutionary theory.
It's amazing how seemingly separate areas of research
right?
can come together to create a more complete understanding.
Absolutely.
We've journeyed from ancient Greece to the dawn of modern biology.
It's been quite a journey.
It's a testament to human curiosity and our desire to understand the world around us.
Absolutely.
And that's where we'll leave it for now. But our journey through the history of scientific thought isn't over yet.
Ready for more.
In part 2, we'll delve into the 20th century and beyond.
Okay.
We'll explore the mind-bending world of relativity, quantum physics,
I love it.
and the vast expanding universe.
Let's do it.
Stay tuned.
Welcome back to our deep dive into the history of scientific thought.
We're ready to jump into the 20th century.
Yeah, in part 1, we journeyed from ancient Greece to the dawn of modern biology.
Right, setting the stage for some truly revolutionary ideas.
Now, get ready to explore the mind-bending world of 20th century science.
Where our understanding of the universe takes a radical turn.
Buckle up because things are about to get weird.
It's going to be a wild ride.
First up, we're zooming into the invisible world of atoms,
Okay.
where scientists began to unravel the secrets of matter.
At its most fundamental level.
And it all started with the discovery of something completely unexpected.
Like what?
Radioactivity.
Oh yeah, that's where things start to get really interesting.
Right. Scientists like Henri Becquerel and Marie Curie were pioneers in this field.
Fascinated by these strange invisible rays.
Right, emanating from certain elements.
And their work wasn't without risk.
Yeah, Marie Curie paid a high price for her groundbreaking research.
It's incredible how these early researchers ventured into the unknown.
Right, often with little understanding of the dangers.
Took true courage and dedication to unlock the secrets of these invisible forces.
But how did they go from studying these mysterious rays to actually figuring out the structure of the atom itself?
Yeah, it's not like they could just look at an atom under a microscope.
Right, they're way too small for that.
So they had to come up with clever experiments to probe its structure indirectly.
Okay, so what did they do?
Enter Ernest Rutherford.
Okay.
His famous gold foil experiment.
I've heard of this one.
It completely revolutionized our understanding of the atom.
So remind me how it worked.
Basically, he fired these tiny particles, called alpha particles,
Okay.
at a thin sheet of gold foil.
Uh-huh.
Most of the particles passed straight through.
Which makes sense.
You'd expect that, right?
Yeah, like shooting bullets through tissue paper.
Exactly. But here's the thing.
What?
Some of them bounced back,
Right.
as if they'd hit something solid.
Wow. That's unexpected.
Imagine throwing a tennis ball at a thin sheet of paper and having it ricochet back at you.
That's crazy. What did Rutherford make of this?
Well, he concluded that the atom wasn't this solid sphere as previously thought.
Okay.
Instead, it must have a tiny, dense, positively charged nucleus at its center,
Okay.
with electrons orbiting around it at a distance.
So this experiment completely changed our picture of the atom.
From plum pudding to something more like a miniature solar system.
Out with the old, in with the new.
And this discovery laid the foundation for our modern understanding of atomic structure.
But things were about to get even weirder, right?
Oh yeah, much weirder.
We're talking about Albert Einstein.
Here we go.
And his theory of relativity.
Which completely shook up our understanding of space, time, and gravity.
Einstein's theories are notoriously mind-boggling.
They challenged our most basic intuitions about the universe.
Okay, let's start with special relativity.
Published in 1905.
What was so groundbreaking about it?
It completely changed our understanding of space and time.
Okay, I'm trying to wrap my head around this.
It's like saying that depending on how fast you're moving, time could actually slow down for you.
Wait, so time isn't a constant?
Exactly. Einstein showed that time and space are not absolute, but relative to the observer.
That's trippy.
And that the speed of light is constant for everyone, regardless of their own motion.
Okay, so time is not this universal metronome ticking at the same rate for everyone.
It's more like a fluid, dynamic entity that's influenced by motion and gravity.
It's hard to wrap my head around that.
It's a radical concept.
But it's been confirmed by experiments, right?
Countless experiments.
And it's essential for understanding all sorts of phenomena.
Especially the behavior of particles at high speeds.
So we have special relativity, and then 10 years later,
Einstein publishes his theory of general relativity,
which takes on gravity,
revolutionizing our understanding of it.
So Newton's apple goes out the window.
Kinda.
How does Einstein explain gravity?
Instead of a forcement, Einstein described gravity as a curvature in space-time.
Space-time.
Caused by the presence of mass and energy.
Okay, go on.
Imagine a bowling ball on a trampoline, warping the fabric.
Okay, I can picture that.
That's kind of like how mass warps space-time.
So massive objects like planets and stars.
They create these dips in space-time.
And that's what we experience as gravity.
Exactly. It's not that objects are pulling on each other.
Okay.
But rather that they're following the curvature of space-time.
Created by those massive objects.
It's a completely different way of conceptualizing gravity.
My mind is bending.
And it's been incredibly successful in explaining all sorts of phenomena.
Like what?
The bending of light around massive objects.
Whoa, okay.
And even the expansion of the universe.
So light, which has no mass, is still affected by gravity.
That's right. The universe is a playground for these mind-bending concepts.
It's incredible. And these concepts have real-world applications, too.
Oh, yeah, for sure.
Like GPS.
General relativity is essential for GPS to function accurately.
Wow. It uses these incredibly precise timekeeping
To determine your location.
So even the most abstract theories.
They can have these tangible impacts on our everyday lives.
It's amazing. But let's shift gears now.
Okay, where are we going?
From the grand scale of the cosmos to the realm of the very small.
Okay.
The world of quantum physics.
Where things get even stranger.
More counterintuitive.
You might say reality itself gets a little fuzzy.
What is quantum physics all about?
It deals with the behavior of matter and energy.
At the atomic and subatomic levels.
And in this realm, the rules of classical physics simply don't apply.
So it's like a whole different set of rules governing the universe at its tiniest scales.
Exactly. Things get really weird down there.
Give me an example of something that's different in the quantum world.
Well, one of the most bizarre concepts is superposition.
Okay.
Where a particle can exist in multiple states at once.
Multiple states at the same time?
Until it's observed.
So it's like a coin being both heads and tails simultaneously.
Until you look at it and force it to choose a state.
Wait, so the act of observation influences reality.
That's one interpretation.
It's like the universe doesn't decide what it is until we look at it.
It's one of the most mind-boggling aspects of quantum mechanics.
Okay, that's wild. What else?
Another strange phenomenon is entanglement.
Entanglement.
Where two particles, no matter how far apart, can be linked in a way that measuring one instantly affects the other.
So they're connected even across vast distances.
It's like those two coins, no matter how far you separate them, are always flipping in sync.
That seems to defy the laws of physics.
It does. And these quantum weirdnesses aren't just theoretical curiosities.
They have real-world applications, right? Like in quantum computing.
Exactly.
Which are being designed to solve problems that are impossible for our current computers.
Problems that would take classical computers billions of years.
So quantum physics is not just about these mind-bending paradoxes.
But also about potentially revolutionizing technology.
It's a whole new frontier of scientific exploration.
And it's an area of active research with incredible potential for the future.
Okay, let's zoom back out now.
From the quantum realm.
Back to the grand scale of the cosmos.
Okay.
Back to Einstein and his theory of general relativity.
All connected.
Right. It turns out it also laid the groundwork for understanding the evolution of the universe itself.
How so?
Well, general relativity predicted that the universe should either be expanding or contracting.
Right.
And in 1929,
Edwin Hubble.
He makes a groundbreaking observation.
That distant galaxies are moving away from us.
So the universe isn't static.
Nope. It's expanding.
Like a giant balloon being inflated.
It's a mind-blowing concept.
So what does this mean about the past?
Well, Hubble's observations provided the first evidence for the Big Bang theory.
The Big Bang.
Which states that the universe originated from an incredibly hot, dense state billions of years ago.
So the universe had a beginning.
And it's been expanding ever since.
Okay, so the universe is expanding.
But what does that mean for its future?
Does it keep expanding forever?
That's a great question.
Well,
one that cosmologists are still trying to answer.
So we don't know.
The fate of the universe depends on a delicate balance.
Between
the gravitational pull of matter.
Okay.
And something called dark energy.
Dark energy.
Which seems to be accelerating the expansion.
Dark energy, it sounds like something straight out of a science fiction movie.
I know, right?
But it's real.
It's one of the biggest mysteries in science.
What is it?
We don't know what it is, but we can observe its effects.
So we know it's there.
It acts as a kind of anti-gravity.
Okay.
Pushing things apart and causing the expansion of the universe to speed up.
So the universe is not only expanding,
but something we don't understand is making it expand even faster.
That's both fascinating and a little bit unnerving.
It highlights how much we still don't know about the universe.
There's so much more to learn.
But that's what makes science so exciting.
It really is.
This constant process of discovery, pushing the boundaries of our knowledge, and seeking to understand the world around us.
From the smallest particles to the largest structures in the cosmos.
It's an incredible journey.
This journey through the 20th century has truly been a whirlwind of mind-bending discoveries.
From the atom to the expanding universe.
And it seems like there are still so many mysteries left to unravel.
There are so many questions left unanswered.
What groundbreaking discoveries are waiting for us just around the corner?
That's what we'll be exploring in part 3.
I can't wait. Welcome back to the final part of our deep dive into the history of scientific thought.
It's been quite a journey.
We've journeyed from those ancient Greek philosophers
to the mind-bending discoveries of the 20th century.
Now we're stepping into the cutting edge of science,
where researchers are pushing those boundaries of knowledge.
Tackling some of the biggest mysteries in the universe.
It's an exciting time to be following science.
So what's been shaking up the scientific world lately?
What discoveries have got scientists buzzing?
Well, one of the most significant breakthroughs in recent years
was the discovery of the Higgs boson.
In 2012,
this elusive particle,
predicted by Peter Higgs back in the 1960s,
plays a crucial role in explaining why particles have mass.
The Higgs boson, often called the God particle.
Right, although that term can be a bit controversial.
It does kind of capture the importance of this discovery.
For sure.
But how did they actually find it?
It's not like you can just, see it under a microscope.
No, definitely not.
It took the largest and most complex scientific experiment ever built.
What was it?
The Large Hadron Collider.
At CERN.
Scientists smashed protons together at nearly the speed of light.
Wow.
Creating this shower of particles.
And amidst all that subatomic chaos,
they detected the fleeting signature of the Higgs boson.
It's like finding a needle in a haystack.
But on a cosmic scale.
What a testament to human ingenuity.
Absolutely, and the power of international collaboration.
It's incredible.
The discovery of the Higgs boson was a major victory for the standard model of particle physics,
which describes the fundamental forces and particles that make up the universe.
But it also raised new questions.
Like what?
And pointed towards the need for an even more complete theory.
What's still missing from our picture of the universe?
Well, one of the biggest mysteries is the nature of dark matter.
Okay.
And dark energy.
We've talked about those before.
We know they exist.
Right.
We can observe their effects.
On galaxies and the expansion of the universe.
But we have no idea what they're made of.
Dark matter and dark energy, it sounds like something straight out of science fiction.
I know, right?
But you're saying these are very real phenomena.
That make up the vast majority of the universe.
So most of the universe is made of stuff we don't even understand.
It's humbling, isn't it?
It is, and incredibly intriguing.
It's driving some of the most exciting research in physics and cosmology today.
So what are some of the ideas out there?
Well, to explain dark matter and dark energy, there are a lot of theories.
Okay.
Some physicists are searching for new particles that could make up dark matter,
Okay.
while others are exploring modifications to our current theories of gravity to explain dark energy.
Interesting.
It's a wide-open field with huge potential for groundbreaking discoveries.
It's incredible to think that we're still in the early stages of understanding these fundamental aspects of the universe.
And who knows what the future holds?
What other areas of research are pushing the boundaries of scientific knowledge?
Another exciting area is the field of quantum computing.
Oh, yeah, we touched on that in part 2.
Right. Quantum physics deals with that strange and counterintuitive behavior of matter at the atomic and subatomic levels.
Yeah, and researchers are now using these quantum phenomena to build entirely new types of computers.
Exactly, quantum computers.
They're not just faster versions of our current computers, right?
No, not at all.
It's a completely different way of processing information.
They exploit the principles of superposition and entanglement.
To perform calculations in a way that's fundamentally different from classical computers.
And this opens up the possibility of solving problems that are simply impossible for even the most powerful supercomputers today.
So problems that would take our current computers billions of years to solve.
Quantum computers could potentially crack them in a fraction of the time.
It sounds like quantum computing has the potential to revolutionize fields like medicine, material science.
And artificial intelligence, even.
Absolutely. It's a rapidly developing field.
With the potential to transform many aspects of our lives.
It's amazing to think about how far we've come.
In our understanding of the universe.
From those ancient Greek philosophers pondering the nation of matter.
To modern physicists exploring these mysteries of dark matter, dark energy.
And that strange world of quantum mechanics.
It's a testament to human curiosity and our drive to understand the world around us.
And this journey of scientific discovery is far from over.
There are still so many mysteries to unravel.
So many questions left unanswered.
It's a never-ending quest for knowledge.
A constant process of exploration and discovery.
And that's the beauty of science, isn't it?
It really is a huge thank you to The Science Book, Big Ideas Simply Explained.
For guiding us through this incredible journey through the history of scientific thought.
And to you, our listeners, thank you for joining us on this deep dive.
We encourage you to keep exploring this fascinating world of science.
Because there's always something new to discover.
And who knows what groundbreaking discoveries await us just around the corner.